So a very good morning to you, dear students. So I'm happy to meet you after a break. So we are in page number 15 now. So I think we should be starting from pressure exerted by liquids. Okay. So I am just putting together a few videos, compiling few videos from YouTube, which would explain the topics that are after this page number 15 லேந்து இருக்கக்கூடிய எல்லா டாபிக்கையும் ஒரு வீடியோவா கம்பைல் பண்ணி நான் போட்டிருக்கேன். இப்போ why I am here is to just give an introduction about what we are going to see in those videos. Okay, first. So the first part of it, just there is a video to explain liquid pressure. And what you see in page number 15, the diagram that is activity 3, ஒன்று இருக்குது பாருங்க. இது நம்ம வந்து 6th 7th லே படிச்சிருக்கிறோம். 6th standardலே வந்து we have seen this, that liquids exert pressure at different depths. இல்லையா? So the pressure of a liquid is maximum at its depth என்றதுக்காக ஒரு cylindrical jarல 3 ஹோல் போட்டு ஒரு எக்ஸ்பெரிமெண்ட் பார்த்திருக்கோம். Okay, that we have learned it already, and that explanation is more than enough. Okay, so you can also watch the video that I just added here. So that would explain what liquid pressure is. Okay, இப்போ இது ஏன் இங்க முன்னாடினா பாஸ்கல்ஸ் லா இங்க கொடுத்திருக்காங்க அதே பேஜ்ல. பாஸ்கல்ஸ் லா தெரியணும் அப்படின்னா பேசிக்ஸ் வந்து ஆக்டிவிட்டி 3 தான். You should know what is liquid pressure and the different points that are involved. Okay, pressure at a particular point in the liquid அப்படின்னா cylindrical jarல ஒரே லெவல்ல 3 ஹோல்ஸ் போட்டோம்னா water coming out of the jar will be with equal force னு படிச்சிருக்கிறோம். ஓகேங்களா? இப்ப Pascal's law என்ன எக்ஸ்பிளைன் பண்றாரு? Pascal's law is named after the scientist Pascal. Okay, so Pascal's law explains that the pressure exerted at a point on a liquid is equally distributed throughout the liquid which is present in an enclosed chamber. For example, in the activity la வந்து ஒரு rubber ball எடுத்துக்கிட்டு on the surface of the rubber ball we are making holes, okay, at different places using a pin, and you just close the holes with a sellotape. Take a syringe, fill it with water, inject the water inside the rubber ball now. So the rubber ball will be filled with water now. இப்போ என்ன பண்ணுங்க, try to remove the sellotape and squeeze the ball. Ball அப்படி press பண்ணும்போது என்ன ஆகும்? Water will come out through all the holes. எல்லா துவாரங்களில் வழியாகவும் நீரானது வேகமாக பீச்சி அடிக்கப்படும். இல்லையா? With a force it comes out. So when you just look into the force that is experience that in every hole இருக்குது இல்லையா? ஒவ்வொரு துவாரத்தின் வழியாகவும் எவ்வளவு வேகமாக தண்ணீர் வெளியே வருகிறது என்பதை நாம் உன்னிப்பாக கவனித்தோமே ஆனால் it will be equal. இது எதனால் சாத்தியமாகிறது அப்படின்னு பார்த்தோம்னா, when you press the ball, the pressure is applied at different places over the ball, and what happens? It is equally distributed throughout. இதுதான் Pascal's law. So you will also be watching this in that video. Okay, this is just an introduction that I am giving to you, and we will also discuss about the applications of Pascal's law. That's fine. The next concept that we will be discussing is surface tension. Surface tension ஐ பற்றி. இப்ப surface tension அப்படின்றத சுருக்கமாக டிஃபைன் பண்ணோம் அப்படின்னா, the surface of every liquid, any liquid that we are taking, the surface of any liquid, okay, will act as a stretched rubber band or a rubber sheet. இப்ப நம்ம பலூன்லாம் பார்த்திருக்கோம் இல்லீங்களா? பலூன் ப்ளோ பண்ணோம்னா அப்படியே எக்ஸ்பேண்ட் ஆகும். வெடிச்சிருச்சுன்னா இங்க நம்ம என்ன பண்ணுவோம், அந்த பலூன் ரப்பரை வந்து அப்படி இழுத்து பிடிச்சி இந்த சின்னதா ஒரு புட்டை செஞ்சு விளையாடுவோம். நீங்க பார்த்திருக்கலாம். இப்ப அது மாதிரியான ஒரு ரப்பர் ஷீட் அப்படி பிடிச்சிட்டே இருக்கிறோம். விட்டோட என்ன ஆயிடும்? the rubber sheet will shrink in size. இல்லையா? இது மாதிரியான ஒரு ப்ராப்பர்ட்டி தான் surface of liquidsல இருக்கும் அப்படின்னு சொல்றாங்க. Okay, it will be like a stretched membrane, always trying to minimize this area. அப்படியே இழுத்து சின்னதாகிக்கிட்டே இருக்கணும். அதனால தான் ஒரு drop of water, விரல வந்து தண்ணியில நினைச்சிட்டு ஒரு drop of water நம்ம விடுறோம்னு வைங்க, அது வந்து ஒரு tear மாதிரி நம்ம எப்போதுமே ஒரு drop இப்படி போடுவோம் இல்லைங்களா? அது மாதிரி தான் வரும். But as it falls down, you will see that the water shrinks in size and forms the shape of a sphere. Why is it and how is it possible that it takes a shape of a sphere அப்படின்னா, that is because of surface tension. Okay, and there are some experiments I have added to it, understand, to explain surface tension also. Kindly watch that part of the video. The next one is viscous force. Viscous force is very easy to explain. You take two different liquids. One liquid is water. The other one you can take honey. Understand? If you try to flow down the liquids on a inclined surface, ஒரு சருவலான ஒரு நிலப்பரப்பு இருக்குது இல்லையா, ஒரு சறுக்கு மரம் மாதிரி ஒரு நம்ம வீட்டில் இருக்கிற ஏதாவது கிளாஸ் பிளேட்டோ அதை வச்சுட்டு add a few drops of water on top and find out how fast it runs over the slope. Okay, அதே மாதிரி add a few drops of honey on the other side. Compare both the movements, you will find that the honey takes a larger period of time to just drain out. அதுல வழிக்கு வர்றதுக்கு ரொம்ப நாள் ஆகும், ரொம்ப நேரம் ஆகுறது. காரணம் என்ன அப்படின்னு பார்த்தீங்கன்னா, the density, that is the viscous force of honey is larger when compared to that of water. The reason is because water is a less denser liquid when compared to honey. Okay, so that concept about viscosity is discussed in the video. The next part of it is friction. Friction, okay, is it a useful or a unuseful force அப்படின்னு பார்த்தோம்னா ரெண்டுமே. ஓகே, இருக்கிற இடத்தை வைத்து friction நல்லதா கெட்டதா அப்படின்றத டிஸ்கஸ் பண்ண போறோம். Before getting into it, frictionனா என்ன அப்படின்றது, friction is a opposing force acting in the direction of the applied force. ஓகே, டேர்ம் வந்து கொஞ்சம் காம்ப்ளிகேட்டடா நம்ம சொல்ற மாதிரி இருக்குது இல்லைங்களா. இப்போ ஒன்றும் இல்லை, இப்போ உதாரணத்துக்கு இந்த இது இருக்குது. ஓகே, வாட் இஸ் திஸ்? திஸ் இஸ் what you call power bank இல்லையா. இதை ஐ திங்க் யூ ஆர் ஏபிள் டு see it in the video. ஓகே, இட்ஸ் visible. இந்த பவர் பேங்கை வந்து நான் இப்படி தள்ளுறேன். I am pushing it to one side. Okay, it's not moving over the book. I am trying to push it. I think you are able to see that in the video. Understand? When I am trying to push it, this is the direction of the applied force. The definition says in the direction of applied force. But this is the direction of applied force in which the power bank is moving. But where is the friction? The friction is between the bottom surface of the power bank and the surface of the book. ஓகே, அந்த ஏரியாவில் தான் ஃப்ரிக்ஷன் இருக்குது. அப்போ அந்த ஃப்ரிக்ஷனல் ஃபோர்ஸ் என்ன பண்ணும், அப்ளைட் ஃபோர்ஸ் இந்த டைரக்ஷனில் இருக்கும் அப்படின்னா இந்த டைரக்ஷனில் ஃப்ரிக்ஷனல் ஃபோர்ஸ் ஆக்ட் ஆகும். இட் இஸ் அ ஆப்போசிட் ஃபோர்ஸ் ட்ரைங் டு அப்போஸ் த மோஷன் ஆஃப் த பாடி in the direction of the applied force. So that is a frictional force. இப்போ இந்த frictional force எங்க இருந்த அட்வான்டேஜ் எங்க இருந்த டிஸ்அட்வான்டேஜ்ன்றத பத்தி தான் இந்த வீடியோல நம்ம டிஸ்கஸ் பண்ண போறோம். இப்போ இதை மட்டுமல்ல, அட்வான்டேஜஸ் அண்ட் டிஸ்அட்வான்டேஜஸ் டிஸ்கஸ் பண்றதுக்கு அப்புறமா ஃப்ரிக்ஷனல் ஃபோர்ஸை அதிகமாக்குவது எப்படி, குறைப்பது எப்படி. அதிகமாக்குறது எங்க அப்படின்னு பார்த்தோம்னா, இப்போ நம்ம ஷூஸோட பாட்டம்லாம் பாருங்க, சோல் இருக்குது. So that's made up of rubber or sometimes plastic also. Imagine if the floor is very smooth, it's a tile floor with lot of mud over it. மணல் இருக்கும் சில டைம்ல, நடந்திருக்கும். அது மாதிரி சமயங்கள் டைம்ல நம்மளுடைய ஷூஸ் வந்து if it doesn't have a proper grip over the floor, என்ன ஆகும், ஸ்கிட் ஆகி வழிக்கு விழுந்துடுறோம். காரணம் என்ன அப்படின்னு சொன்னோம்னா, இந்த மணல் வந்து ஃப்ளோருக்கும் ஷூஸ்க்கும் நடுவுல சிக்கிக்கொள்ளும் பொழுது என்ன பண்ணுது, ஃப்ரிக்ஷனல் ஃபோர்ஸை ரெடியூஸ் பண்ணிடுது. இட் ரெடியூசஸ் த ஃபோர்ஸ் ஆஃப் ஃப்ரிக்ஷன் அண்ட் therefore we skid and fall away. Even if there is some banana peel or like oil over the floor, we skid and fall because the force of friction is considerably reduced. Okay, இப்போ இது மாதிரி சமயங்கள்ல நம்ம ஷூஸோட சோல் எப்படி இருக்கணும், நல்ல கிரிப்பை கொடுக்கணும். இட் ஹஸ் டு அப்ளை மோர் ஃப்ரிக்ஷன் அப்படின்ற போது, ஓகே, தேர் how to increase the friction. Understand? Innone, when you apply brakes in a vehicle, the vehicle has to stop immediately. If the tire doesn't have proper grooves, அல்ல கோடு கோடா இருக்கும், பட்டன்ஸ் சொல்றோம் இல்லையா, அது இல்லைன்னும் போது என்ன பண்ணும், பிரேக் அடிச்சா ஒரே இடத்துல நிக்காது, கொஞ்ச நேரம் இழுத்துட்டு போய் நிக்கும். The reason is because there is less amount of friction. Okay, so the methods of increasing and reducing friction is also discussed in the videos. Okay, with these topics we come to an end of the lesson. இப்போ along with this video, I am also posting a few pages from your workbook. Understand? And the workbook has come to the school and you have not received it so far. Maybe when you come and ask the book depot, they may give you also. Okay? So since you don't have the workbook with you, I am just posting the pages, taking a Xerox, scan of it and then posting it here. And I expect you to finish it during this week. And in the next week, Okay, I will post the answers for it. But don't expect me to post the answers. I want you to work with it. We will have a discussion and then write the answers. Sometimes I won't give you the answer also, because I want you to work. Don't expect work to be done easier. Go through the book, finish the workbook. Understand? And later on, if you have doubts, we will discuss the answer. I am not posting the answers. Okay? And let's watch the videos that come so that the explanation will be clear.
Have you ever wondered why a large ship floats but a small pebble sinks? In this video, we'll learn about floating, sinking, pressure, and density. Density is a measure of how heavy something is relative to its size. It can be calculated using this equation. Try calculating the density of a wax candle that has a volume of 2 centimeters cubed and a mass of 1.9 grams. Pause the video to work it out. We can use density to predict whether an object will float or sink when it's placed in a liquid. If the object is more dense than the liquid, it will sink. If the object is less dense than the liquid, it will float. Water has a density of 1 gram per cubic centimeter. Will the wax candle with a density of 0.95 grams per centimeters cube float or sink in water? That's right, the density of the candle is less than the density of water, so it will float. Lead has a density of 11.3 grams per cubic centimeter, and liquid mercury has a density of 13.5 grams per cubic centimeter. What would happen if a block of lead were placed in a beaker of liquid mercury? Pause the video while you think. The lead would float in the liquid mercury. So that's a fairly easy way of explaining why solid blocks float or sink. There is another thing to consider: buoyancy force. All liquids are made up of particles that can slide over each other. When the particles collide, pressure is produced. The pressure in a liquid varies with depth and density and gravitational field strength. In a column of liquid, the water will pour out through the holes in the side of the container. The water that pours out of the hole at the bottom of the container travels further than the water that pours out of the hole at the top. This is because the water at the bottom of the container is under greater pressure than the water at the top. The mass of the particles pushing down on the water at the bottom of the container creates more pressure. The deeper the liquid, the greater the pressure. We can use these facts to derive the formula, where P equals pressure, ρ equals density, H equals depth, and G equals gravitational force. Imagine a cuboid submerged in a tank of liquid. The distance from the surface of the liquid to the bottom of the surface of the box is greater than the distance from the surface of the liquid to the top of the surface of the box. So H2 is bigger than H1. Because P equals ρgh, the pressure on the bottom surface due to the liquid must be greater than the pressure on the top surface. This results in there being more force on the bottom surface of the box than there is on the top surface. The difference between these two forces cause there to be a net force upwards called the buoyancy force or upthrust. If the buoyancy force is greater than the weight of the object will rise up through the liquid. If the buoyancy force is less than the weight of the object will sink. If the buoyancy force is equal to the weight of the object will still float. Who didn't like playing in ball pits when they were a child? Now let's imagine a room filled with these balls constantly moving around in different directions. This is how molecules in a gas move. In this video, we're going to discover more about amazing gases and the effect temperature and pressure have on them. Have you ever wondered why the cork explodes out of a champagne bottle? Or the fizz when you open up a shaken bottle of Coca-Cola? This is all to do with gas and pressure building up inside the bottles. So let's have a look at pressure in gases in a little more detail. Gases exert a pressure on any surface which they are in contact with. The more particles that hit the walls of the container, the higher the pressure. Like when you shake a Coke bottle, and as it fizzes, the bottle feels harder than before. This is the gas particles pushing against the plastic bottle. So we have the equation: pressure is force per unit area. We also see the effect of pressure in gases when we blow a balloon up too much, and it pops. This is because we've increased the pressure of the air molecules pushing against the rubber balloon too much. Heating also increases pressure. Why is that? As a gas is heated up, the particles gain more energy and move around more quickly. They then hit into the walls of the container harder and more often. This understandably increases the pressure, and if the pressure is too great, the container can burst. Again, think of popping balloons and bursting tires. Ever read on your deodorant can a warning that says not to leave it in the sun? This is because inside the can is a gas, and as we just discovered, heating up a gas causes the pressure to increase and can result in that can exploding. Not a good idea. So what happens if we then cool down the gas? This time, the particles have less energy, and so less pressure is being exerted on the container, which is why balloons shrink and become sad and saggy. Now, it's time for something none of us like. Needles and syringes. Thankfully, there are no injections for us today. We're just learning that needles and syringes work due to pressure in gases. When the plunger of a syringe is pulled out, it causes the volume in the chamber to increase. This increased volume causes the pressure inside to decrease. Now we have created a vacuum that wants to repressurize to normal atmospheric levels. Since it's a sealed system, except for the needle into your arm, the only fluid available is your blood, which gets sucked into the chamber. Your blood then reduces the volume, and so the pressure increases back to normal. Pause the video and fill in the missing words. Did you get them right? So there we have the effects of volume, temperature, and molecules on the pressure of a gas. I hope you enjoyed today's lesson, and I'll see you next time.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.
Good morning, children. Today we shall learn more about pressure, especially Pascal's law. So now we know water or any liquid can apply pressure in all the directions. Let us perform one more experiment. We take a rubber ball filled with water and now we pierce holes in it with pin in different places. If we press it hard, water will rush out of all the holes with equal force. You know, the scientist Pascal said if we apply pressure at any point of confined fluid, it will be transmitted without any change to every other point in the liquid, which means the pressure will be transmitted equally in all the direction. So, the pressure we applied is transmitted equally in all the direction. Thus, water is coming out of all the holes with the same pressure. This is known as Pascal's law or Pascal's principle. So to sum up what we learned today we learned about Pascal's law. This is also known as the principle of transmission of fluid pressure. According to Pascal's law, an external pressure applied to a fluid in a closed vessel is uniformly transmitted throughout the fluid, which in simple word means pressure applied on one point of the confined liquid is transmitted equally in all the directions. That's all for now. Bye bye, children. Hello everyone. We already know about Pascal's law, but you should also know that application of this simple law is enormous. You must have heard the term hydraulics. Hydraulic machines are machinery and tools that use liquid fluid power to do simple work. According to Pascal's law, the pressure applied to an enclosed incompressible fluid is transmitted unchanged to every part of the fluid. Here, there is a model of simple hydraulics that uses the principle. It is a U-shaped tube which has two arms and they are closed by two leak-proof pistons. Now here, the two arms have different cross-section. One arm has much larger cross-section than the other. So here, we say A2 is greater than A1, where A2 and A1 are the cross sections of the two arms of the U-shaped tube. Now, when we apply force which is equal to F1 to left piston, then it will create pressure which is equal to F1 divided by A1. As we know, pressure is equal to force by area. Now, the cross section of A1 is small. So, we can generate greater amount of pressure easily by applying a moderate amount of force. Now, this pressure will transmit equally throughout the fluid and reach the larger tube. Now, here in the larger piston, the pressure would be F1 by A1. So, the total force working on the larger piston would be F2, and force as we know is pressure multiplied by total area. Here, pressure is equal to F1 divided by A1 and area is equal to A2. So, what is F2? F2 is equal to force divided by area. So, this becomes equal to F1 divided by A1 multiplied by A2. Now, in case you have not noticed, the upward force applied on the second tube or the second piston is A2 times the force we applied on the smaller tube or the piston. So we see force gets multiplied many times. Thus, we can generate enough push to lift a heavy car by applying a much smaller downward push in the smaller piston, that is in the left arm. Thus, hydraulics is used to generate huge force by applying much smaller force in many heavy vehicles like bulldozers, trucks, etc. Hydraulic brake is used in heavy vehicles. Hydraulic lifts is used to lift heavy objects. So we see a simple rule can have such huge applications in real life. That's all for now. Bye-bye.
Surface tension is a physical phenomenon that we observe in our daily life. Raindrops take a spherical shape. Tears of wine are seen in a glass on pouring an alcoholic beverage in it. Formation of spherical soap bubbles. All these are examples of surface tension. Read this Puzzle article for a better understanding of this phenomenon. Quick fact: surface tension in water arises from high interactions between water molecules, known as hydrogen bonding. As the value of surface tension of water is high, water has a high boiling point. The force of attraction between like molecules in a liquid lends it a tendency to contract at the surface. Hence, the surface is said to be under tension. Surface tension is the property of a liquid surface to resist external force. It is the reason why the surface of a water body looks like a stretched membrane. Surface tension causes capillary action, due to which water travels through the stems of plants, and blood flows through the small vessels in our body. Following are the basic concepts about molecular forces that we need to know before understanding surface tension. Cohesive forces are intermolecular forces between similar molecules. For example, the force of attraction between two water molecules is cohesion. Adhesive forces are intermolecular forces between dissimilar molecules. The force of attraction between a water molecule and air is adhesion. Range of molecular forces is the maximum distance up to which intermolecular forces are effective. A sphere drawn with the molecule as the center and the range of molecular forces as the radius is known as the sphere of influence. Surface film is the layer of surface of liquid whose thickness is equal to the range of molecular forces of attraction of the molecules at the surface. What is surface tension? Consider the molecules A, B, C of a liquid, let us say, water, as shown in the adjoining figure. Molecule A is well inside the water, B is at the surface film, R, and C is on the surface. The sphere of influence of molecule A is totally inside the liquid. Hence, it is acted upon with an equal and opposite cohesive force from the remaining molecules. Therefore, the net force acting on molecule A is zero. A part of the sphere of influence of molecule B is above the surface of the water. Hence, adhesive forces from air molecules act on molecule B. Due to this, the cohesive forces from molecules below and around B pull it down. Thus, the net unbalanced downward resultant cohesive forces pull molecule B down in the water. Half of the sphere of influence of molecule C lies in the water, while the other half is in the air. The cohesive forces act against the adhesive forces, and C is pulled inside due to the resultant unbalanced cohesive force. Due to these cohesive forces, the surface area of the liquid reduces. Thus, surface tension can also be defined as the force per unit area necessary to expand the surface of a liquid. Practical applications. Apart from mercury, water has the greatest surface tension of any liquid. Let us take a look at some examples of surface tension of water. Water striders are insects that can walk on the surface of water because of surface tension of water. Mosquito eggs can float on water because of its surface tension. Kerosene is sprayed on water so that the mosquito eggs sink and the breathing stops. Warm water is used for washing purpose as heating increases the surface area and reduces surface tension. This action is replicated by adding detergents to cold water. A needle placed on water can be made to float due to the surface tension of water. If the surface is ruffled, the needle will quickly sink. Other examples of surface tension. The test for jaundice involves the use of surface tension properties. Sulfur powder is sprinkled on the urine sample. If it does not contain bile, the sulfur powder floats due to surface tension. If bile is present in the sample, the surface tension of urine reduces and the sulfur powder sinks. Toothpaste contains soap, which reduces the surface tension and helps it spread freely in the mouth. Disinfectants have low surface tension, which allow them to spread through cell walls of bacteria. Surface tension of some liquids. Liquid surface tension N/M. Water at 20 degrees Celsius 0.0727. Soapy water typical 0.0370. Mercury at 20 degrees Celsius 0.4355. Tissue fluids typical 0.050. Glycerin 0.0631. Thus, surface tension is an essential physical phenomenon. As mentioned earlier in this Buzzle article, it has various day-to-day practical applications.
Everyone knows what a huge splash you can make when you dive bomb into a swimming pool. Right on the surface, the water feels hard, which is why you can hear such a big noise when you land.
That's because of surface tension. All the molecules on top are pulled tightly together. They form a skin like a weak layer of plastic wrap.
Here's a cool way of showing how surface tension works. Put some milk into a bowl, make sure it's a room temperature. Now squeeze a few drops of food colouring. It just sits there because it hasn't broken the surface tension. But watch this. A couple of drops of detergent splits up the molecules in the middle, and all the colours are sucked towards the edges. That's what happens when you break surface tension.
We know that in solids, there is a strong attractive force between molecules. As we heat the solid, this attractive force becomes less effective because of increased vibration of molecules because of heat energy. As the attractive force becomes less and less effective, movement of particles, relative to each other, starts. Addition of more and more energy results in more and more movements, and solid starts converting to liquid. For a given temperature, different liquids showcase different magnitude of relative movement between molecules. This relative movement is measured in terms of physical quantity called viscosity. A liquid is more viscous when there is strong attraction force and relative movement of particles is less. and a liquid is less viscous when there is less attraction force between molecules and there is an easy movement of particles relative to each other. If we compare engine oil and water, engine oil is more viscous force compared to water. Now let's understand what happens when a solid object moves in or on the liquid. Now, imagine a boat is moving on water. With boat, water molecules on top layer are also moving. As we move deeper and deeper, movement of particles reduces. Since there is an attractive force between molecules, deeper molecules try to prevent surface particles to move with boat. And to overcome this force, boat need to apply more force. Force which prevents relative movement of particles or layers of liquid is called viscous force. More the viscosity, more will be the viscous force, and more efforts one needs to put to move layers of liquid on top of each other. If we drive boats on oil and water, boat on oil will consume more fuel because oil is more viscous compared to water, and thus more energy will be required to overcome this force.
How do things move in real life? Say a ball is moving on a flat ground and there's no external force acting on it. Will the ball eventually come to a halt? Yes, it will. Have you ever wondered why? Say you're skating on an ice rink and your friend is skating on the road. Whose movement do you think will be smoother? Definitely yours. When you hold a bottle in your hand, why doesn't it just slip through and fall? Sometimes when you're walking around in a mall, do you remember seeing a caution sign to warn you about the floor being wet? What explains all this? The answer is friction. The reason why the ball eventually comes to a halt is because of the force of friction. The reason why skating on an ice rink is easier because the force of friction is lesser there. The bottle doesn't slip through because the force of friction between your hand and the bottle doesn't allow it to do so. If the floor is wet, the friction offered by it reduces and there are chances that you might slip and fall. So what is this friction we're talking about? It's quite easy to understand its concept. Friction is nothing but a force. It is the force exerted by a surface where an object moves across it. In the first case, when the ball is moving in this direction, the force of friction is acting in the opposite direction. The force of friction offered by the ice rink floor is lesser than the force of friction offered by the road. Hence, skating on the ice rink is easier and seems effortless. The bottle does not slip down because the surface of your hand offers a friction in the upward direction. And in the case of the floor in the mall, the soapy water reduces the friction offered by the floor. In the coming lessons, we'll learn a lot more about friction. We'll see the factors affecting friction. We'll understand if friction helps us in our everyday life or not. And we will also cover the different types of friction. I ended the previous lesson with a question. I asked you if the force of friction comes into play only when the two things are in relative motion. Let's discuss this in detail. Let's say you want to move the stationary sofa in your living room and the sofa is really heavy. What happens when you give it an initial push? Yes, you're right. Nothing happens. The sofa doesn't move even though you're applying a lot of force. Why do you think the sofa doesn't move? Well, the answer is static friction. The force that you apply is balanced by a frictional force by the floor. And this force is applied in the direction opposite to your push. This force is nothing but static friction. The concept of static friction is really amazing. Why do I say that? The reason why I say that is because it is a self-adjusting force. As you increase your force of push, the force of static friction increases too, and the forces are still balanced. Now I know what you must be thinking. After a few seconds, the sofa begins to move, right? What happens to the static force then? Let's discuss this with the help of a simple graph. We assume that the force you apply is the horizontal force represented by the x-axis, and the frictional force applied by the floor is represented by the y-axis. Now, as you increase the horizontal force applied, the frictional force is also increasing accordingly to keep the sofa at rest. This continues till a point where the sofa just starts moving. And that's where the static friction ends and the sliding friction begins. The sliding friction is more or less constant if you notice. This part of the graph is static friction. It's when the sofa is not moving in spite of the force you're applying. And this part of the graph is sliding or kinetic friction when the sofa begins to move. The point around which the sofa just begins the movement is called the breakaway point. Is there anything else you noticed in the graph? Why is this line at a lower level than the maximum static frictional force? The reason is simple. If you have ever pushed a sofa or some heavy object on the floor, you would have realized that pushing it is a little easier when it's in motion. Yes, it's because the sliding friction is lesser than the static friction that's offered by the floor. That was the concept of static friction for you. So we've seen three kinds of friction so far: static friction, sliding friction, and rolling friction. Can you place them in the increasing order of force being applied by each? Yes, static friction is more than the sliding friction, which will be more than the rolling friction. In all the examples we've seen so far, we've only considered friction between solid parts: ball on a floor, box on a table, or roller skates on the ground. In all cases, both the objects were solid. Does friction come into play only when solid parts are involved? Is there any other kind of friction we haven't seen yet? Do watch our next video to know more. Here's a cube that's placed on the table. We know that if we are pushing the cube in this direction, then the force of friction will act in the opposite direction. If we apply a force along the left, then the force of friction will act towards the right and vice versa. The force of friction will always oppose the applied force. What are the factors that affect the friction? Let me give you three situations and then you tell me what it depends on. The first situation is when an object with a smooth surface is moving on a surface which is very smooth. Second, in which the object has a smooth surface and the surface on which it moves is rough. Or the object has a rough surface and the surface on which it moves is smooth. And in the third case, the surface of the object as well as the surface of the table is rough. In which situation do you think will the force of friction be the highest? Intuitively, you will tell me that in the third case, the force of friction will be higher than these two cases. And in which situation will the force of friction be the lowest? It'll be the first case as both the surfaces are very smooth. Though there will be friction here, it will be lesser than that in the other two cases. If we just look at these three situations, we can say that the force of friction increases as we go towards the right. So can you tell me the first factor on which the force of friction depends? Yes, it depends on the nature of the surface on which the object moves and the nature of the surface of the object. Yes, it depends on the smoothness or the roughness of the two surfaces which are in contact with each other. If you want to find out if this is true, here's what you can do at home. Create an inclined slope on a table like this and mark a point somewhere on it. Now from this point, let a small cylindrical shaped object move down. You will see that it reaches a particular point and then stops. Next, place sandpaper right under the slope and leave the object from the same point as before. What do you notice? You will see that the distance covered by the object is lesser in the second case. And you probably know why. The surface on which the object rolled was rougher in the second case. And clearly, the force of friction was more. Why is friction caused though? It is caused due to the irregularities on the two surfaces in contact. What do I mean by irregularities? Now, even though the table looks smooth, if we zoom into the surface, we will see the surface irregularities. Even the surface of the object has irregularities. Though they are minor, they still exist. Now, the irregularities on the surfaces lock into one another. So, whenever we have to move an object, we need to overcome the irregularities. But why is the friction higher on rough surfaces? It's because rougher the surfaces, more will be the irregularities. And if the irregularities are more, then more force will be required to overcome them. So the first factor affecting the friction is the nature of surfaces. Is there any other factor you can think of? Let's say there are two bricks on a table. One weighs 2 kilograms and the other weighs 5 kilograms. Now I apply equal force on them towards the right. Which brick do you think will go further? Remember that they are both kept on the same surface. And the surfaces of the bricks are also the same. On applying the same amount of force, you will notice that the lighter brick covered more distance than the heavier one. What does this tell us? It tells us that the friction also depends on the force with which the two surfaces are pressed together. If the two surfaces are pressed harder, the friction will be more. Why is that? Because of the second brick's greater weight, it presses on the table with greater force. Since its surface and the table surface are pressed together harder, the interlocking between the irregularities is more. And this results in more friction. So mainly, there are two things on which the force of friction depends: the nature of both surfaces and the force with which the two surfaces are pressed together.
Welcome to edupediaworld.com. In today's video, let's learn about advantages and disadvantages of friction. Friction plays a very important role in the mechanics of life, our everyday life. It would just be impossible for a person to walk on a friction-free surface. Friction is also necessary for operations of many small things in our daily lives like the belts, pulleys, clutches, and brakes. Nails and screw remains fixed where they are driven because of friction. Friction helps us to walk or move over any given surface. It would be difficult for us to walk if there is no friction between the ground and the floor. Friction also helps us to stop and control movement. For example, the brakes of car or the brakes of bike. Without friction, it is difficult for anybody to sit on the chair or even stand at a place. It is also difficult to fix a nail on the wall or a screw in a wooden block if there is no friction. Friction helps in supporting a ladder inclined to a wall, as shown in the picture. Had there been no friction, the ladder would just fall off from the wall. Now, it is the force of friction between the belt and the pulley that helps in rotating various parts of a machine. We have seen most of the advantages of friction. Let us now see disadvantages of friction. When one body moves over other, the frictional force comes into play. In order to overcome this frictional force, some energy is used up which dissipates in the form of heat energy. And the perfect example is right in front of you. That is, when we rub our hands, there is friction created between our hands. This friction causes the heat to be generated, which is lost. Now, when the heat is lost, we feel warm after rubbing our hands. What does this cause? This causes wear and tear. The wear and tear is due to the excessive friction. And this leads to reduction in the efficiency of every machine that we see around us. Now, after we have gone through the advantages and disadvantages of friction, let us now study how can we increase the friction or reduce the friction. Let's first take a look at the methods of increasing friction. There are three methods as shown. Firstly, by making the surface rough. Secondly, by using a dry surface. And thirdly, by increasing the weight of the object. Now let us have a look at each one of them. What happens when we make the surface rough? As we have studied earlier, if a person is trying to move an object over a smooth surface, then the force of friction is less over a smooth surface. Whereas over a rough surface, the force of friction is very large, and thus it is difficult to move an object. So if we want to increase the friction, we need to increase the force of friction and hence use a rough surface rather than using a smooth surface. And what happens when we make use of dry surface? Now we have two different cases over here. In the first picture, you can see we have an object and a surface, but between the object and the surface, we have a layer of oil, which is a smooth surface. Whereas in the other case, the object is directly placed over this. So now what happens when I apply a force to each of these objects? The objects which is placed over the oil obviously moves very easily and moves faster because it is over a smooth surface, that is over the oil. This is basically because over a smooth surface, again the force of friction is very less and so the object moves very fast. Whereas in the second case, the force of friction is very large and hence the object doesn't move so freely. It just goes to a smaller distance and stops. So by making use of a dry surface, we can increase the friction. Again, by increasing the weight also, we can increase the friction. Let's see what happens here. Take a look. The 5 kg's weight, which is lesser, moves faster and moves very easily over a surface as compared to a 15 kg weight. That is because if the weight is high, if the weight is more, then it is difficult to move this object over any surface. That is exactly because, again, the force of friction for a heavy weight over a surface will be more than as compared to the force of friction in case of a lighter object. So we have seen that there are three methods of increasing the friction. Firstly, by making use of the rough surface. Secondly, by using a dry surface. And thirdly, by increasing the weight of the object. Let's now study some of the methods of reducing friction. First method is use of lubricating oil. There are various liquid lubricants which are thick or thin oils that are used in the machines to reduce the friction. For example, you must have all plate carom boards wherein you use a fine powder to reduce friction so that all the wooden coins move freely on the carom board. In other cases, high-speed machinery. In such high-speed machinery, films of gas under very high pressure are used as very successful lubricants. Next is use of ball bearings. In order to reduce the friction between the parts of a machine, ball bearings are often used. Here, hard steel balls are introduced between the moving parts. This reduces the friction considerably. The free wheels of bicycle, the axle of motor cars, and the shaft of electric motors are examples of places where ball bearings are often used. These ball bearings reduce the friction and makes the various parts of machinery move very freely. Third method is use of polished surface. We also again know that a very polished or a smooth surface will have very less force of friction and hence it reduces the friction. Use of air cushion is another method of reducing friction. If the two solid surfaces are separated by an air cushion, then the frictional force is reduced to a much greater extent. This is because the two surfaces do not come in direct contact with each other. This is also the principle of hovercraft, which can travel over rough land or sea with the help of an air cushion. Thank you for watching the video.